Why do rational expressions have holes or vertical asymptotes? Have you ever wondered why some rational expressions seem to have missing points or lines they just can't touch? Let's break it down in a simple way. Rational expressions are fractions where both the top part, called the numerator, and the bottom part, known as the denominator, are polynomials. Sometimes, these expressions can become undefined, especially when the denominator equals 0. This is where things get interesting, leading to holes or vertical asymptotes in the graph. First, we need to identify the values that make the denominator 0. These values are called excluded values because you cannot evaluate the expression at these points. To find them, you set the denominator equal to 0 and solve for the variable. Now, whether an excluded value results in a hole or a vertical asymptote depends on how the numerator and denominator are related. If a factor that causes the denominator to be 0 also appears in the numerator, we have a hole. This means that when you simplify the expression, that factor cancels out. Even though the expression is undefined at that value, the graph has a hole, which is like a missing point. The function approaches a specific value from both sides but never actually reaches it. On the other hand, vertical asymptotes occur when a factor in the denominator causes 0 but does not cancel with the numerator. At these points, as the variable gets closer to the excluded value, the function tends to grow without limit, either toward positive or negative infinity. This creates a vertical line that the graph approaches but never crosses. For example, let's look at the rational expression x minus 2, x plus 3 over x minus 2, x minus 5. Here, the factor x minus 2 appears in both the numerator and the denominator. When we simplify, this factor cancels out, but the expression remains undefined at equals 2. This results in a hole at that point. However, when we look at x equals 5, this value makes the denominator 0 without any cancellation, leading to a vertical asymptote at that point. Understanding these concepts is essential when working with inequalities and rational expressions. Knowing where the holes and vertical asymptotes are helps us determine where the expression is undefined and how the graph behaves around those points. When solving inequalities that involve rational expressions, it is crucial to exclude these values from the solution set and consider how the expression behaves near them. In summary, rational expressions become undefined where the denominator equals 0. If that 0 factor cancels with the numerator, we see a hole in the graph. If it remains only in the denominator, we have a vertical asymptote. These features are key to understanding the behavior of rational expressions in algebra.